Alrighty, in this lesson our goal is to solve rational equations, and those are equations that look like this mess on the second page of your notes, which to me looks a little bit scary. Luckily, rational equations, as we know, are made up of fractions, and they follow all of the same rules as fractions do. So we're going to imagine for a second that we're helping our little cousin, or maybe some freshman out of the hallway, with their math homework, and they have to reduce fractions and add fractions and subtract fractions here. This would be a great warm-up for you to just do on your own, so feel free to pause the video and do that. I'm just going to write the solutions here in a second, but we're using all of the same skills in this lesson as we would use here on this elementary school work, so it's a good refresher. Alrighty, so notice I show quite a bit of work here. We're going to annotate this work here in a second, so if you didn't show these steps, make sure you add some of them. Particularly all these things I crossed out are important. All these operations where I get common denominators are important. And then you guys know how to add and subtract fractions. You add or subtract the numerator. Denominator stays the same, right? Because we're adding 3/5 plus 1/5. We're still talking about fifths when we're done. And then to rewrite, I'm going to say in a very specific way, we multiply or divide out a fancy form of 1. So fractions are really all about this idea of multiplying by a fancy 1, right? So often we kind of just memorize the steps and we don't really think about how it works. But for example, the reason we cancel out 2 over 2 here is it's really 1, right? The reason why we cancel out 24 over 24 is it's really 1. The reason why we're even allowed to multiply by this 2 over 2 to rewrite our 3/4 is because it's a fancy form of 1. I had a math teacher that called these fafus, which means a fancy form of 1. And it makes sense to give them kind of this silly, memorable name because it's actually really important, right? This is how we work with fractions. Okay, let's talk about why it would be useful to tackle a function like this, and then that will generate sort of an easy example where we can practice using our fafus, and then we'll move on to this harder example here. So one example of a situation where we would use an equation like this is in a work problem. So this is where we know two people who work at different rates, and we're imagining that they work together. So in this case, I'm teaching a little bit faster than Miss Stackler, but we're teaming up and we're working together for 6 hours, and we want to know how long would it take me and how long would it take Stackler. And we're just going to follow the model here. So A and B are the hours it's individually, right? So Stackler is going to be A. That's going to be X hours, and then 5 hours less for me would be X minus 5 would be my B, and then T would be 6. So my equation then would be 1 over X plus 1 over X minus 5 equals 1 over 6. All right. Now, all we have to do here is get a common denominator and add these. And to get a common denominator, I'm going to use my fafu, my fancy form of 1. Notice to make these denominators the same, I have to multiply this one by X minus 5, and I have to multiply this one by X over X. Whatever I do to the numerator, I have to do to the denominator, because I'm multiplying by 1 and I'm not actually changing the value of each piece. So when I multiply these out, I get X minus 5 over X times X minus 5. So that was my first piece, and then I get X over X times X minus 5. And I didn't actually change my 1/6 at all, right? Now I can add them. I get on top X minus 5 plus X would be 2X minus 5. Again, the bottom did not change at all. It stayed the same. And I haven't changed the other side yet either, still a 1 over 6. Now, there's a couple different ways I could solve this. I could cross multiply, right? I'm going to choose instead to get a common denominator on both sides. So what I look for is what each denominator is missing. On my left-hand side, I'm missing a 6, and it needs to be a fafu, right? It needs to be a funny form of 1. So 6 over 6 I multiply by, and on the right, I multiply times x minus 5, which is my denominator from the left-hand side, and again, I have to do the same thing on top. And that really is the same as cross-multiplying. I'm going to just rewrite the equation to start. So on top I get 6 times 2x minus 5 equals x times x minus 5. And both now are going to be over 6x times x minus 5. Now, what I can do now is I can multiply both sides by the denominator. So they're the same. And they just cancel out, and then I get an equation I can solve. And you can think of it as cross-multiplying if you want, if you're already comfortable with that. But that's why cross-multiplication works. Now here's my next step. I distribute, right? So 6 times 2x, 6 times negative 5, etc., etc. And notice I have a quadratic equation. So what I want to do is get everything on the same side, get my equation equal to 0. So I get x squared, negative 5x minus 12x is negative 17x, and then plus 30 equals 0. And then I can solve by factoring in this case, although quadratic formula would work too if you couldn't figure out the factorization. In this case, 2 times 15 makes our 30, and if we make them both negative, they add up to negative 17. Okay, so here's my solutions, and let's do a little sanity check here. So remember, Stackler was x, and I was x minus 5 hours, right? So if x equals 2, that means she's taking 2 hours, and I am taking negative 3 hours. So in that case, this doesn't really make sense. So let's assume it takes Stackler 15 hours, and it takes me only 10 hours. Now here, we're going to use the same strategy as we used in the previous example, even though it looks a little bit scarier. I do want to know what factors are in my denominator, so I'm going to start by factoring the right-hand side. I'm just rewriting it, right? And the left-hand side I'm going to leave alone for now. Except my 1 I'm going to turn into 1 over 1. And now before I move on, I'm going to note, right, that based on what I have here, I know that x is not allowed to be negative 4 and x is not allowed to be negative 5 because they're not in the domain. So that's good to note that, because this equation very well could spit out one of those answers, and we just know that it's not going to work as a solution. Okay. From there, I'm just going to work with my FFUs, my funny forms of 1, and get a common denominator. And notice 1 needs both, right? So I'm just rewriting everything so that I can add them. And then I want to multiply everything out and combine like terms. So we'll do my first set of factors. Notice we already knew that because we started with that in our denominator. And then when we have common denominators on both sides of the equation, we can multiply them out on both sides. And I'm going to go ahead and combine some like terms too. So there's our equation. It's again a quadratic equation. So we want it equal to 0, and we're going to solve by factoring. So we may think we're done and we have 2 solutions to our rational equation. We would be wrong, right? So remember, we noted that x was not allowed to be negative 4 before we solved this. So we're going to cross that one out. That's called an extraneous. So we've successfully solved our rational equation, but x equals negative 8 is our only solution.